गुड मॉर्निंग टीचर्स. जसे साई सर आता म्हणटालो खूप दिसांनी मेळटात, पण म्हाका दिसता खुबश्यो गोष्टी चेंज जाल्यात तितल्यान. वन थिंग वर्थ मेन्शनिंग, आमी हांगा जेन्ना उलयतात बसून सगळ्यांक खबर आसतले थंय एक युद्ध चालू आसा. पीपल आर लुजिंग देअर लाइव्स, दे आर लुजिंग देअर प्रॉपर्टीज, राइट? No news channel ever talks about the people who are losing their properties, right? They are all busy trying to show what this politician said, what that politician said. Let us take a moment to realize what we call ourselves a human society, right? So let's also take a time to realize the pain, the suffering which some human beings are going through. And at the same time, let us hope that, just like sports, maybe an activity like programming, and as you will see why I'm talking about it, an activity like programming will help us connect to people across nations, across cultures, and help us probably make a good human society, right? So let's not try to make a joke around any war efforts or something like that. Let's see what we can do being a good human. But around that, as you said, like, a lot of things changed since we met. तुमच्या कडल्यान फीडबॅक खूप येवपाचो आसा. भुरग्यांनी कितें केला, कशें केला, खुबशे व्हिडिओज पावलेत, खुबश्या व्हिडिओजचे खुबशे प्रोजेक्ट्सांचे व्हिडिओज जाले, कॉम्पिटिशनां जाली, भुरग्यांनी पार्टिसिपेट केले, नव्यो गोष्टी शिकल्यो, आनी मेन म्हणजे स्कुलां सुरू जाली. सो सगळ्यांचो कितें फीडबॅक आसा? कोण कितें सांगपाक सोदतलो? Because today is a big change. अजूनपर्यंत आम्ही जे पळयताले that was just scratch, right? You drag and drop and do something. Today is actually a big change. We are moving away from doing some drag and drop things to actually typing. That is the whole theme of 7th standard, mostly focusing on the keyboard, right? Keyboard text, keyboard shortcuts, and all of those things. So 7th standard is largely keyboard, correct? So before we make this change, any learning you would like to share? How was the reaction from the students? Any questions from the parents? Any difficulties? No? Maybe some of that thing will come after a coffee. So anybody read about Kojo? Who all have downloaded and installed? Everyone? Raise your hands. Okay. What about those who have not raised their hands? Okay. So as we are seeing here, right, there are certain things about Kojo, and mostly the language. So when we were doing Scratch, what was it like? It was all drag and drop. Like, we were able to build some games and everything, but there was no serious programming into it. We were drawing patterns. Some people even created games. Till that point, it was fine. But what value does it add to a child's life apart from just being able to express his or her ideas? So that is why we are taking a step further. We are saying, let us try and build abilities to explore computing further. And this is where being able to code using text is very, very important, right? We will discuss both. First, we will discuss, let's get used to coding by typing. There is always this initial fear, right? It must be difficult and all those things. And that is why we generally go for things like Kojo and other drag drop things, right? Let us explore how it feels. What can we do? Let us get used to it first. So that is why we are having this long period of series, a month-long series happening on every Saturdays. And you are going to get time in between to practice. So next time, idea is next time when you will come, do come to us with a feedback. And in between also do share your feedback, all right? So I hope everyone must have installed Kojo. And this is how the interface looks like. Has all of you started it? We'll go very slowly today, okay? And before we go further, right, let me know if the voice is not audible and anything. Okay. So there are samples here. Can everyone see? The interface looks almost the same for literally everyone. Whether you're using Linux, whether you're using Windows, whether you're using Mac, the interface looks absolutely same, right? So you must be able to see samples here. And in the samples, you have samples like getting started. There are next steps, right? Multiple turtles and all those things. So there is something around physics. There is something around generative arts. We'll see all of that. The syllabus for the 7th standard does not go this deep. Because just like the 6th standard, right, which was not about Scratch, we were using Scratch as a tool. 7th standard is also not about Kojo. You're using Kojo as a tool to learn something else, right? So there are animation and games. So if you were talking about Moonlander and all those things, right? So all those games are here. You can see there is Flappy Ball, Car Ride, and there is something around music. Music is there for the 8th standard if you have gone through the syllabus, right? Then there is general programming with input, output, and all those things. And there is something around math. There is something called showcase also. So do look at those things. Let's look at some samples around. There is something around image layout, right? So there is a fractal. So we can go over there and you can see that fractal is being drawn there. And it's quite possible that if you just look at it, this looks very difficult kind of code, but don't read the code for now. Let's just focus only on the showcase and the samples, right? There are circles, right? Then there's something about multiple turtles. So face. You saw what happened just now? So there were like multiple turtles. They drew various part of the face in parallel. Right? So do take a look at that. So we'll definitely talk about all those concepts going further. In animation and games, you can see that there is a Moonlander. Well, you lose. So, oh. So it also bounces from the top. I'm very bad pilot. I mean, right? Again, might look like a big code out there, but we'll see how to simplify all of that stuff. There is something around robot simulation. So yes, you can do computer vision, artificial intelligence, right? Arithmetic, let's not get into that. And then there is this showcase. It's if you see various programs. These are some of the advanced ones. So there is something called as an inner eye. So essentially you can make some beautiful patterns. You can even export those things. You can say right click and export as an image. You can actually save it as an image directly, right? There is a car ride. So you can play this game. Okay, I crashed. So do try that out. And the point that I was talking about is take a look at the languages. So the point is there are people from various cultures, various countries also participating in Kojo programming. So doing this also helps you connect with other people around us. More than that, do take a look at a code exchange section. So Scratch had a Scratch Studio, right? So there is also something called as the code exchange. So lot of people here, right? They try to do something and they try to push their code here. So here is Aditya he did a Republic Day greeting. It's all done using Kojo. And to give you an idea, right? This is not like a sprite that is colored or something. You can create all those color effects from Kojo. And this is the code. And these are the kids doing it. So I can possibly try and show more. Maybe, can you look at this effect here? Right, so there are crows, there's sun, so entire scenery drawn. Especially take a look at the reflection effect. Right, all done using Kojo programming. Take a look at the reflection of the sun, especially. Right, so, and this is the code here. And something to keep in mind, these activities, the code that you see here, are done by kids, okay, except maybe one or two. Republic Day greeting, entirely including the text. Right, and if you want to see where all of that is, you can see that he's setting a font. Right, he's setting the size, he's setting the text, all of that. So this is what Kojo can enable our minds to do explore the code exchange also. While we'll be doing this activity, let us also try and push our changes to code exchange also. I'm just trying to show. If you want to get hypnotized, you can take a look at this. Anybody likes Angry Bird? Right, so feel free. This is how it is drawn. And there are multiple ways of doing it, just like anything else. So some people have drawn absolutely similar idea. So once you get an initial concept, right, you can just keep applying it to various figures that you can see. Yeah, so this was the tree. We did this, right? We did this even in Scratch. But here you can see that there is a background effect there, which is being applied. Some very interesting color effects. There's a wallpaper there. For some interesting reasons, right? This is what I like. If you see, we had drawn stars, but this takes the same code behind it. Not only draws a star, it also aligns those stars in a shape of a circle. The stars are themselves rotating, if you might have seen. And then there is a shadow effect, and in the background there is a gradient. Right, so you can see that. Pretty interesting ideas out there. This is just simple circles and the curves put together. So you can go from something very simple to something very complex. This is something probably I would really like to show. You can't see what this is just by the output. So this is something very interesting. So as you click your mouse pointers, it draws those triangles around. Anyway, so a lot of great things. If you're talking to any of your students, right, do show them what is coming up to them in the 7th standard, so they should get some excitation as well. And we could probably start. So let's stop this. Let's say new. Let's give it a name. Maybe I'll say Kojo session. Right, and maybe we just clear this off. And what do we see? We see a turtle. Why do we see a turtle? So unlike Scratch, right? So Scratch had some aspect of turtle graphics, not all aspects of turtle graphics. Scratch had some aspect of turtle graphics. You get majority of them in Scratch, in Kojo. So there is a turtle there. Keep in mind, there is nothing like a costume section, display or a backdrop section, nothing. All that is there is this code block for you and this output window. And if at all you try to print something, that will come in the output pane below. If there are any errors in your script, you will see it in the output pane. That's it. Right? There is no other complexity. There is nothing like command, motion palette, display palette, all those instruction palettes. Then there is costume editor and all that stuff, because it is not required. You can draw your shapes and you can use them in the same code. And that is all we are going to see. So this looks bit odd. Sometimes it looks complicated, but it takes practice and will be there with you. But let us try and make it as simple as possible. So let us go to window to start with. Okay, let us go to window. Sorry, not window. Tools, and you will see that there is something called as a turtle controller. Click on that. And what it does is it actually starts a Kojo code itself. It's not like something which is not there in Kojo. You can see how it is written over here and everything. And I would just like to adjust it bit up, right? And minimize this so it fits my screen. And I have certain commands given to me. I have something like left 90. I have forward 50, right 90, hop 50, erase, left 10, forward, and all those things basically. So there is left 90, left 10, forward 50, forward 10. So 50 is like 50 steps, 10 is like 10 steps. Correct? So right is essentially which direction you want to face. Right is towards your right side, left is towards your left side, and then you see the angle there. Hop is essentially like a jump. So remember the way turtle works, right? So turtle is like a person or a robot that is holding the pencil down on the paper. So if you make the turtle walk, wherever the turtle is walking, it will draw. But if the turtle jumps, well, in real life, turtles don't jump. If the turtle jumps, you won't see that line between those points, right? So that's hop. And then there is obviously erase. What this code does is very, very interesting. This is the code written in Kojo itself. But what it does is interesting. Keep in mind, look at below, okay, as I click this. Just try and see what happens below, okay? I'm going to first say, and see the facing of the turtle, okay? It's facing up, okay? I say forward, it goes forward. I say right, it turns towards right. I say forward, okay? I say right, forward, right, forward, right. What just happened? Square. It did something else also. So if you see the output pane below, it actually gave you the Kojo program to draw this square. So what I can do is I can go below. It is also giving a message saying paste the generated program below into the script editor and run it to produce your drawing. So I can copy this. You can say Control C. I can clear this whole program and I can say Control V and then run it. Right? So we used a Kojo program which was already there to do some clicking here and there and build our own Kojo program. But that Kojo program also gave us a program that we can then copy paste and do our own things. So what do you think the clear does? Anyone? No coffee, no shouting. Come on, teachers, you are teachers. So yeah, I like that word whenever I hear it. So if you go to the so there are these Kojo books here, and let us just go over there. It gives a link, and that link has the description of what some of these commands do. So do refer to that. Okay, so the link that I wanted to talk about. Am I audible? No voice? Okay. Behind? Okay. That's the voice of a teacher. Well, let me just find it. Where did that go? No, not strengths. So all the patterns, you can see it over here. There is some part of code given also, and then there is this reference turtle, right? Clear. Just read this part. Let me make this bigger. So this is what happens on clear. Can you read what's given there and identify what is the concept we were learning in Scratch? What is the concept? Clean slate. Does exactly that. Right? You don't need to do that whole block. The moment you say clear, it does exactly that. So we can go and say it. So let's say there is something called, let me just comment this out. And the way you comment it out, right, is you can just say control and press slash. So it just comments the whole thing out. And let me also comment out clear. And let us see what happens if I just run it. It goes further. If I run it again, it will go further again. Or for example, if I just say turn, so I'll say right, right? See, goes further. But if I again say right, I mean, if I just run this whole thing again, it is not like by default it is going to face up. So it's going to take effect from that point. But if I say clear, so let me just comment out these both things. Take a look at what clear does. Just one clear command. See where the turtle is facing, okay? Most importantly, it's facing downwards. So if I run it, what happens? Erased everything, it's at the center and it's facing up. But unlike Scratch, there is something interesting out here for you as well. Just at the click of it, you can right click and you can see that there is show axis. So this is the axis and this is 0, 0. But if you need further help, there is show grid also. Oh, this one. Okay. Can you see this? Now you can enable or disable it here. But if you want, you can do it via code also. So you can say show axis and it draws the axis. And you can say show grid and it gives you a grid. All right. So this is just clear. But more than that, let us see what else it can do. And there is show protractor. So now you don't need to use a graph paper. The kids can see the protractor right on the screen. All right. So you can move it around. And if you press control, so I think it's shift. If you press shift, you can even rotate the protractor. Right. So that's about protractor. You can also show a scale. So if you really need to measure how much pixel is from this point to this point, or how many steps are there from this point to this point, it's 50 steps. Right? And similarly, if you press shift, you can rotate it. Then you can say, don't show it. So there is reset pan and zoom that basically, so if I like, for example, zoom it up and I say reset pan and zoom, it goes back to its normal size. And obviously there is full screen canvas and everything. So the whole canvas becomes full screen, just like what used to be there in Scratch. Right? So we saw there are a lot of similarities with what Scratch can do. And then there are a lot of differences also. I can also go back down here in the output pane and clear the whole panel. Especially take a look at the syntax. Okay. So any command or any function, so this is like a block. And any block is called like this. You write a name of that block and give 2 brackets. But to a great extent, you can do it without that as well. So I can say something like clear, forward, 100, and this works. It always works. You don't always have to put brackets, but if you are passing inputs to the command like here, you have to use brackets. So that brackets define that this 100 is an input to this forward. Make sense? So this is the general syntax. If there are no inputs, you don't need to do that. A perfect example is this. So clear, I can either write it this way or I can just write it this way. So similarly, forward, and let's try and draw a square. So I'll say right. Okay. Again, let's say forward. But let's try this without this here. And you will see that it actually turns. Because right does not, I'm not passing any inputs to right. I can actually skip the brackets completely. Okay. So and that's the square. Everyone wants to try this out? Just take some time, give this part a try, and then we will move ahead. So let's say if you're drawing this, what is the problem you noticed with this approach? It was very easy to get random colors here. You didn't have to think about fill and spin or anything. But did you notice the problem? The problem is no matter what you do, you will never get the same output in terms of colors. Why do you think that is the case? Because it is random, right? But nothing is actually random. So if, let's say you end up deciding to give an assignment or students want to do something and they make a design, they want to achieve some kind of clarity there, and suddenly the zebra appears multicolored. Doesn't look right? How can you ensure I want to use random, but no matter how many times I run it, the color should look the same. See the problem. Like it, but if I go and try to run it or I submit this and somebody tries to run it, the color should look the same. But they should still be different. Yes. So one way, correct. So there is something called as a seed. You can define how the random number starts. And that is called as init random generator. So if I say and press control space, right? Don't always try to complete the whole thing. Okay, it's not going to work. There is an autocomplete given. So init random generator, and it says seed. Can you see that? So if I give some value there, no matter how many times I run it, it will always come same. So if I say 100, right? See, no matter how many times I run it, it will always show the same pattern. It will change if I change this value here. See, now it will always show these colors. And if I say 100 again, and now if you have written the code exactly like this on your machine, it should produce exactly the same output. Right? So two ways of generating different colors. You define a color, then you spin it, or you use random color. Random color can be? Yes. Spin also can be used. So do you know this platform is developed in India, right? Kojo. So it's a scheme designed in India using a tool designed in India, right? And the language that students are learning here is Kala. And the same language is used to develop this tool. So if any students wants to say, okay, how do I build something like this, right? And if he learns Scala, he can actually learn how they can build something like this. So there is a range that that person, if he has interest, can go to. That's another reason to choose this tool. And generally, it happens, right? Fine, as in we do something, but I want to build something like this. How should I do it? I want to build a game. How do I know how that game is built? The source code is available for this tool also. Maybe I can. Can you see that? Here? That's the code for Kojo. So it's written in exactly same thing. See, def. We use these two commands already, right? Pen color, set pen color, and set pen thickness. So the same language used to build a tool which students are actually learning. So if any parent comes and says what they are doing, they're just drawing things, right? You can now actually say them. They are actually using the same language over which this tool is built, right? So and the source code is also available. All right. So it's one. Is it already a lunch break? Now? So हांव चित्तालो पोटान कावळे रडटाले कावळे काडची. Everyone has got this, right? So let's draw Kavade. So Kavade कसे काढतात? Just two arcs, right? So let's draw them. Let us use a protractor. And you can see, right? It's, let's say I want to draw it like this. It's something around 120. Start from 0 and go till 120. Right? That makes the one side of the wing. And I'll do the same on the other side. Chalo kavado. I'll first do it and then we'll use blocks and then draw it and draw them at multiple places, right? So left, correct? 120, right? So that angle is 120. Radius, let's say of 50. And the same thing you do on the right. And sorry, right. One thing I forgot, I need to get him back also. Correct? So he has to come back also. How do I get him back? Hop is, but then I'll need to give that value, right? It will always fix to that point. So one way is I complete the remaining circle, don't draw. Okay. So set pen color to none. Sorry, no color. I'm just giving one example. Okay, there are multiple ways of doing this. But before that, I'll need to again define the pen color. And I'll say black. Correct. So first I draw this 120, then I say no, and then complete the remaining one. So 120 minus 360 minus 120 is 240. Is it? 240. So now it has drawn this part and it is back there. So same thing, I'll now repeat for the right side. So right. So you can actually make it smaller. So instead of 50, let's make it 10 maybe. Little bit bigger, I think, right? Play around with the values. And then we will see how we can draw it once and then adjust it later. That is also possible, right? Without changing so many values. This is, I think, something I'll be happy about. 25. Does this look good enough? They're like too much. It looks more like a flower. Kind of like a, doesn't still look like a crow. So before we draw, let us first rotate before we draw the arc by say around 20 degrees. So left 10, something like this. Okay. And then we'll need to, when you will come back here, I'll need to say revert that 10 that I had done. So I'll say minus 10 and then write 10. Write 10 and then here we'll revert that. Yeah, looks better, I think. This is the crow. Let's say I want to repeat this, right? How should I do that? Yeah, first draw this. Everyone got this? Up till this part? Everyone got this? Behind? So now I want to do this multiple times. So how should I do that? I can make a block out of it, correct? So def Kauro. Now it will not draw, obviously. So let us draw them. So we need to take him towards the left, right? So let's go towards the left and keep drawing it. So how can we say go left? So left, first turn left, then maybe hop right, and then Kauro. Yeah. Right. So let us say hop 100, right? Hop 100, left, Kauro. चोड वयर गेलो न्ही. If I keep repeating this, if there is any part of the screen you want to see, you can scroll to that part. Once you get till this part, it is just that part repeating again and again. Now, if you mix this with the pattern that we had done, right, of background, what you will get? Remember the sun? We had this with us, right? So let me just uncomment this and let me say right here before everything, set background, sun with white. हा क्लिअर आहे नाही कावळ्यांबरोबर कासव उठतात. ती एक स्टोरी आहे नाही there's a story right उकलून yeah correct the oldest stick so now they can make the story with it. सूर्याक वयर वरया मातसो हाडिया -147 136. आयले जेवण? हां. चालेल. Okay, meanwhile, not connected, I think now. Okay, so let me share this screen for some time and I'll show you something. So we did this part, right? Up till here. So now we want to play a sound. So let me just increase the font size here. Why is the font size not increasing? Yeah. So we want to show some sound. Can everyone see the screen? And text also. So the only reason I'm sharing something from here is hope the speakers are set right. Yes. Let me know if you can hear the sound. Okay. It's just one line. You have to say play MP3 sound and give a path to any sound. So I'll just turn this. Let me just control the audio here a bit. Okay. So you can try that out. Just one line. You can at least write that line and comment it out. Then if you have MP3 files with you, you can give a full path to that MP3 file anywhere on your disk and it will play.
Somebody could play the sound, I guess. ये जेविल्ले कावळे. Everyone got this? Just input just first few characters, right? And always press control space. This is very, very important because chances are, you see, this is really, really important. M is capital here, S is capital. If you make a mistake there while typing, it will be very hard to realize where things went wrong. So do something like play and press control space. It will give you remaining options and select from there. ये गोईचे कावळे. वो कोड सेव्ह करून दवरपाचो. फुडल्या सेशनाक 12:30 वाजोवपाचो. All right, so I'll stop this and I'll start sharing from here. Before we move ahead, right? Any feedback from anyone, how they are finding it? Difficult, easy? Yes, practice has to be there. All right, should we move ahead? Great. So we did one thing that we had not done before, that is filling up the colors, gradients, not just filling up the colors, right? We even did gradients. We did also those arcs. They were pretty easy. You didn't have to introduce recursions and all those things just because you wanted to draw an arc. Everything becomes pretty direct over here. Color setting, we also played the sound. Let's do something. We have not yet done recursions by the way, so we'll do recursions also. But before we go there, right, let's try to do another thing that we couldn't do with Scratch. Who can identify what was that? Size we somehow managed. There was something that was, can somebody identify? A lot of kids had this question. Filling we did. There was one more question. Rounded edges also we had done. Writing text. Correct. Writing text. There were many questions who were asking this about writing text. So let's write text. Okay. So how do we write text? Just say write. and give the text. There. And you can make it big and you can change the colors just like anything else by saying set pen color, just like we did here, right? Set pen color. You can also set the color here and say, I'll say white, right? And where does it draw? It draws it where the turtle is. Sorry, it doesn't draw it where the turtle is, it draws it at the center, and then you need to move it. So, my bad. But let's make it big, right? Just like set pen color, it is set pen font size. You can say something like 50. And once you've done this, you can go to Google Input Tools. Select Marathi. Copy that. Paste it here. I'm not sure whether this is going to work here, but maybe I can show it here instead. Probably this one does not have the font of it, but I can show it here instead. Let me share this screen and I'll show the same thing. Just check if it works on your system. If you have the Unicode font set up, it should work. So can you see it? Again, let me here play that. So there is something called as, we talked about codecs, right? So once you've done something interesting, if you want, you can see this option here. That's upload to code exchange. So you can always go there, click on it. I think I'll need to share the whole screen. Can you see it? If I click on this, let me close this, show you. If I click on this, gives me a dialog where I can give it a title. I can, obviously I need to register to the code exchange. So it would be good if you register to the code exchange by clicking on this, and to give you email, name, and add a password. And then give a title, select a category, and say upload. So the output that you see here and your code will go, and it will be available in the code exchange for others to see. Great. So if you see now from this point onwards, right? Let me just write this down, okay? Are we good to go ahead? Yes. We'll do that once we reach pictures. Font also can be changed. We'll do all of those advanced things when we'll go to pictures. Should we move ahead? Everyone got? Okay. So let's look at repeating stuff. Okay. So if you see, right, for most part, this is the part that is common. So we do we call Kauro and then we change the position. Right. So essentially, if I repeat these given number of times, I can draw the same thing without having to change my positions. Okay. So how should I do that? So one way is, obviously we already know that, right? So we can repeat things using recursion. So I want to repeat whatever is there here, let's say 4 number of times, 5 number of times, whatever. So how should I do that? So first there was Kavle, and now let's do Kavle. Okay, so def, same thing, right? We need to define a block first, or command or a function, whatever we call it, right? Remember, we used to take inputs. Just like that, here also we need to take an input. Okay, and we'll say steps. If you remember Scratch, when I used to say we want to take an input, it used to ask us whether it is text or a number, true and false, and all this stuff, right? Just like that, we need to mention what these steps is. Is it a text? Is it a number? Is it a true, false, all that kind of stuff. So for now, just take a look. We're just going to say long here. And now we need to define how this is going to work. But let us follow our normal syntax that we used to do up till now. And that was more like if steps is equal to 0, we currently don't do anything. Else here. And towards the end, what should we do? -1, correct. So Kavle steps -1. Now, if I do that here and say let's say 2, I should see 2. Sorry. So I also need to specify towards here something called as unit. So for now, just remember this. This would change a bit when we'll do pictures. Unit basically means no specific type, right? So nothing was written here, so we'll see. Yeah. So we just saw 2 here. If I say 3, L3, say 4, it will draw me 4, and so on. When we'll do pictures, we'll have something coming at this part also. Right now, this is quite similar to what we used to do. Scroll up. Unit. Unit means, see, when you are writing recursion, right? When it is a block, it has to return something. So you have to either I have to give you some number or I have to give you some value. But over here, it is directly drawing things. It is not building any value. So by saying this, it's saying Kavai just gives me unit. It's like nothing. No matter how many times you call it, it will just give you 1 unit of work. That's it. So numbers are of two types. Long is like 1, 2, 3, 4. All those things are numbers. 1, 2, 3, 4. They are longs. But if you have something with decimal, then it is double. So here I cannot say 4.0. It will give an error. See? So if I have any input that requires decimals, where you can say int also, but then kids will get confused. So it is easier to remember, right? So integers are nothing but long sequences of numbers, correct? And decimals contains double numbers with a point. So, just trying to simplify it for kids. Yeah, long and double. If it is, if you don't want to accept decimals, just say long. If you, yeah, decimals. So essentially what I said is not exactly right. Okay. It is not called long because it is long sequence of numbers. There is a reason why it is called long, but yes, long decimals, long double, int, floats, string. Yes, string is for a text. String is for text. C languages also. So the pedagogy aspect will do last session. Okay, good enough. Now, what we would do is, let us say what I want to do is this. I want to show some crows going towards the right, some of them going towards the left, like a V shape. How can we do that? You understood what I want to do? these are going this side, right? I want some of them going this side, like a V. Yes. So who can do that? Let's try that out. So from center, some should go on the right, some should go on the left. खूप approaches असतात. Let's try. That's an activity. Let us see who can do that. So these are all going towards right, right? So we need this, plus we need some going towards the left also. Either like this or like this. From center. कसे? असे जाता नाले असे जाता. Anyone you can try. Yeah. I'll make a round. Who got the outcome? Can you raise the hands? Okay. All right. Everybody is struggling to get this shape. V. And to achieve that, how many hops do you need? So every now and then you need to remember how many hops you took and then get him back, right? Or you need to set the position to 0, 0. Third position. That's an anti-pattern, right? Because now you can't rotate it or move it somewhere else. So how should we solve that problem? So you were all preparing, right? All this while, right from the 6th standard, not to use variables. Why were we saying not to use variables? Even right now, it looks like we haven't used any variables, but there is one variable. Can anyone guess which is that variable? If you see, let's take a look at this code right here. Kaolo. There was this pen color. What about all this left? This was fine. But what about this left -10, then again right? Why was all of that required? Why we did this extra left? So we had to come back to the starting point, right? That's why all this extra code was required. Because we had to come back to that starting point. Why was that making, what was the issue there? The issue was there is a variable in our system. The variable in our system is the turtle itself. Why is it a variable? Because you tell the turtle to do something and it modifies. So it's here, you ask him to go somewhere else, it goes there. So it varies. Anything that varies is a variable. And that variable has been adding all these complexities here. So if you have been struggling to get the V shape right without using hops or set position, that's because there was a variable, just one variable causing all this struggle. That's the reason we are avoiding variables. But there was one variable here still, there was turtle. This was the variable we still had in our scratch coding. That's why we had to always come back to the same position, right? If we are doing move, then we used to always say move minus. Correct? So that was all confusing. That was because there was a variable whose effect we were trying to remove. So what is happening is, if I say left, for example, if I just say don't do anything, right? Let me just comment out all of this, okay? Essentially, I can just say left. So let's do this. Essentially, I say left. This works, but I want the other side to happen. And this will work from any point, right? This will work from any point, but I want the other side to happen equally correctly without me having to bother where my starting point was. But thing that happens is I can't do that because without we knowing, there is an effect which is happening. Take a look at that. The first command left, see, the first command was moving the turtle here. So there was a variable there. The turtle is a variable here. And the next command was occurring from that variable position. So the ordering matters. If I change the order, it becomes an entirely different shape. See? That's the complexity. This complexity is called a side effect. Anything that you do leaves a change in the system. How your second command is going to act depends on what was the first command. And that's the problem. You don't want that to happen. Because always you will now need to keep in mind what was the previous command that happened. Was there some command that had moved turtle to some unknown position? That's the problem. That is the problem that is affecting us, preventing us from rotating things correctly. Pallavi ma'am had posted some questions sometime back. She was trying to make those pictures dance and she was finding it difficult exactly because of that. Let us see how we can avoid it. And to avoid it, what we are going to do is we are going to create an entity out of the basic picture block here. That's called pictures. But imagine it this way, right? Picture is something when executed always happens from the center. It's given. It always happens from the center. But once it is there with you, you can either move it somewhere else, rotate it, move it and then rotate it. But all those things always happen from the center. Got my point? Always happen from the center of the screen, that is from here. You will see it as we go along. And because of that, I never have this issue. I can reorder things in any ways that will exactly produce the same output. And we'll see how this thing simplifies. But one thing you need to realize is picture is basically like taking a page. So every activity is like taking a page and keeping it on top of each other. Transparent page, drawing on it, changing its position and keeping it on another page. That's how it is going to work. So it's all layers. We did layers in GIMP, right? So it's all layers. But if you try to change the layer or anything, it always happens from the center. Make sense? Okay. So let us try this out. What I would do is all this complexity, right, left, right. I'll keep only one left here or just one right. I don't care. But whichever way, the positioning won't matter. Now it produces a different shape, right? Just because I changed the order. We'll see that it doesn't happen. Okay. So how does that work? What I'm going to do is I'm going to create something called as a picture. Okay. So def, and I'm going to just create one wing of it. So left wing. And this is a picture. This is how you create. This is the simplest way you can create one. And inside that, I'll say right or left, whatever. Okay, I can even say left. Doesn't matter. And what you can do afterwards is you can explicitly ask this picture to draw itself. So I can do something like this. Two ways of doing it. I can say draw left wing. See, it draws that. Or even better, sometimes I can say left wing dot draw, and it draws it. Both ways, completely fine. But now this is just one side. How do we draw the other side? Given this one wing, take a look what I'm going to do, okay? Just one change. First, I'll show you what that thing is and how those operations work, okay? See where the center is. That's why I've kept the turtle there. Did turtle move? See, I've put this code inside a picture. I said left, but did the turtle move? Did I try to get the turtle back? No, right? It's drawn it, but turtle is still there. Turtle hasn't moved. No. No, it doesn't. So you just got rid of that variable side effect. No matter how many times I do this, it's going to be just there. Left wing is always going to be there, no matter how many times I do it. So how do I make a right wing? Show you something. If I say left wing with flipped x, because this is an x-axis, right? Oh, I should possibly show the axis. So show axis. Before I do this, let me say left wing dot draw. See, now this is the x-axis, right? And this is the y-axis. So I want it flipped on the x-axis. What will I get? With flipped x, how would it come? And then say dot draw. See, it comes on the other side. The axis itself got flipped. If I say with flipped y, it will come below. See? No change. And this does not mean something has changed in the left wing. Left wing is still left wing. It is not leaving any impact anywhere else. Right? So for example, I said left wing dot with flipped y, right? And then after that, if I say left wing dot draw, left wing is still left wing. The line executed previously has no effect on the line that comes after it. So you don't have to worry, what did I do before? Okay. So let's see how our crow happens now. So this was one way. Let's take the other way. Def crow is, now it's a stack of pictures. Remember, talked about layers, right? Everything is like layers. In each layer, you modify something. So I create a pic stack and I give the layers to it. How do I give the layers? First, I give it the left wing. And then I say the second layer is the left wing itself with flipped X. And this is my crow. And now if I say draw the crow, there you go. And again, as I said, it has absolutely no impact on what is the order. There's absolutely no impact. Whether you draw the left wing first or the right wing first, nothing changes. For that matter, even if by mistake I go and say here right, it still draws the crow. Make sense? Now we have got rid of all variables in the system as of now. There are no variables there. So all this code of doing left, right, hop, and all those things is now just this much. But let me show you another thing, right? Let me draw this cow as well as this crow. Right? What color did this crow came into? Red, right? What happens if I call this cow first? Did it have any impact? No, right? You see, it's red itself. So it's not having any impact. It's behaving like a separate system. So how do I now change the color of this one? So either I can set the color here outside, or I can define the color outside here as well. So I can say with that's stroke colored. And the color here is black. So now it's black. So crow is a stack of left wing, flipped left wing that is stroked with black color. Other way is you define it here. It's not, man. It's not. I'll show you why. Because this assumes that this has to be that. Now you cannot change the color outside. So here I have left only one operation, and I just think about one shape, and that is modified. So a shape that is translated, a shape that is having a different stroke color, and use this word stroke color because stroke is coming to you in SVG. So this has been aligned with SVG. Stroke is the border. All right, keep that in mind. Stroke is the border. So let's say if this was something that was taking an entire shape, right? Let us see, 360, right? And let's say we want to fill this. What we would have done? That's filled with Gandhi ji ka chashma. And you can, this is not just one. So beyond this point, right, you can just say dot and keep modifying it. We'll see how that goes. Okay. So this is about crow. So let's say 120. Okay. Good here up till now. Don't have to remember. Just say dot and press control space. See, come here. Say dot that's. If you want a color to be filled with, it's that filled with. If you want it rotated, it's that's rotated. Yeah. Where? Yeah. Not after draw. Draw means it is drawn. Before draw. Before draw also. So anywhere you can do that. So now this is red, right? So here you can say that's what, rotated. Yeah, even this one works. But if you want to do multiple, then just figure out. So if you want this whole crow to be rotated now to some other angle, here, that's rotated 30. The whole crow is rotated. So you don't have to now worry about where it is moved. You don't have to also worry about how it's been moving around. So a perfect example, right, is the same picture of moving the crow one above the other. How did we do that? We had those crows, right? So let us try doing that, okay? Those 4 crows. Let's see what happens, okay? Crow dot, obviously draw. This is fine. Next, crow dot. So if I want to move, what should I do with that crow? A crow in a different position is a crow that's moved, but the name is called, let's guess it, right? That also works. And it has no impact on anything else. So I can say crow dot with flipped y, because flipped crow will look like that only. But so I'm flipping it on the y side, and I'm saying draw. We'll do that. We'll do that. We'll do the multiple positions of the crows. So first is crow dot draw. So I now need to move the crow, okay? Or I'll also say that's, or rather say if this is getting too much, you can say def black crow. Tell me, ma'am. So try doing this much. Try doing this much and say crow dot draw. Right? So it draws this. Now, if you want to do anything, you need to tell crow what to do with the crow. We can build a row of crows. Exactly. But now, exactly. But we first need to build it, right? So I need to draw a crow here. That flipped one. We'll simplify that because that's having a problem. It's not coming from the center. So 2 crows will look side by side. So once you have got the once you have drawn the crow as an object, or you can go the other way around also. Draw, but that is like putting an extra bracket, right? So you can simply say crow and say draw yourself. It draws it. Now, if you want a different color, there is nothing like you define something before. Keep that in mind. It's not like you do something and then you do something and then you do something. It's like I have something. I can tell that object itself what to do with it. So I have a crow. If I want the crow with a black color, I'll say what I want to draw is a crow that's stroke colored as black. And then I need to tell him to draw. There. So if I only want black colored crows, I can assign this to some other value like this. Def black crow. There you go. So now you don't have to deal with all this. And then draw this black crow. You can build any sequence that you want. Black crow dot draw. Now let's do those other crows, right? Do it this part, okay? Because then we are going to build those vertical things. So this is a shift now from the turtle graphics. There is only one part of turtle graphics here, which is that left. Don't try to type, okay? Use dot and press control space. This is not there in old version. Old version was much more complicated. That's why I sent a message, update. Works. That's because write it outside and then move it inside. Could be some bug. You need to fix that. Where? Which curly bracket here? So this is a stack of pictures. Here we are building the picture. So here it's a command. So here, see, picture is a value, right? But this left is not a value. You cannot assign this left to something else. So you need to make a block of that command, which you can then use anywhere else. That's why it's curly brackets. And notice at any point of time, right, turtle is not moving anywhere. So it's right there. So any measurement that you do henceforth is always from the center. That's as simple as it is. Should we move the crow? How do we move the crow? So we have just drawn the first crow, right? Let us move it. So always remember here, okay, at this point, do not worry about where that shape is going to come or something, because you can always move the shape later without breaking the shape. That is the best part. With this, you do not have to worry about clean slate, any separate clean slate, because no matter what happens, crow is not, the turtle is not moving. There are no variables there. So the whole effort that we are talking about, clean slate and everything, right, doesn't apply anymore. Right? So we have drawn the first one. I'll get rid of this. I'll get rid of the show axis also. Everything else is just fine. And we have the first crow. I think I can even now say clear eye here, because that's not really required. Let's draw the second crow. Okay. And how do we do that? Black crow dot what? It's moved, right? So it's a black flow that's been, which one do you think? Should we use that's filled with, that's rotated, that's scaled, that's sheared, that's stroke colored, or that's translated? Translated. And translated takes X and Y. Keep that in mind. It moves it in the X direction. Positive X is right, negative X is left. And also in the Y direction. Positive Y is up, negative Y is down. Okay. And that is with respect to, and keep this in mind, it's always from the center. Okay. So it's like taking the whole page where that crow is there and moving it up. Okay. So that's how it works. Center doesn't get moved. The whole page itself gets moved. Center stays there. So even if you then move and then rotate, right? the center stays there. So it will move as if that page is rotated from that point. Correct. So if you want to do solar orbits and everything, there's no point now. Just move the object and then rotate it. So all those orbits and everything, right, is just 2 or 3 lines. So we'll see how that works now. So that's translated. Let us see how much. Okay. Let's say some part towards right and some part towards up. So I'll give 2 positive values. We'll adjust it later. Okay, let me say 100 and 100, and then I'll say draw. See, I have 2 crows now. This is the first crow that's drawn. This is the second crow that's translated to 100 by 100. Now let us try and get it closer, right? So how do I do that? Either I keep changing this value and then keep pressing thing. That is one way. I can either use axis and also the grid and calculate, maybe it should be 50 by 50. There is one more way. Okay. And that way is, let me just disable this. Press Control and click on the number. I clicked on the X number here. Okay. And now I can try sort of moving it. So see, is this good enough? Which one works? This one. And then similarly, I'll also press Control and click on the Y value and then try to get it down. Good enough? Maybe I can move it little towards right. Yeah. How do I build the third crow? Copy paste. Copy paste this and copy this again. Once again, that's translated. What's that, man? Yes. There. You want one more? Copy this whole thing. And again, copy this, that's translated. And there is one more code. Obviously, this you can put in a recursion and build this without having to do this much copy paste, but we'll come there one step at a time. Now let's flip it. But you might have seen how easy this would be once it is done. Either you increase the value or do the same thing. So I prevented the calculation by simply adding it once more. Stroke means border. Dot you press. Why is the border called stroke? Why is it not called a border? Yes. In drawing, they are not borders. You do not take a pencil and say, I am giving a border. You say, I am giving a stroke. Scroll down. Full block, will put it in the pick stack and flip that. And this is what makes this even interesting is just before draw, if you say flip, it goes on the other side. So take a look at this. Okay, so this is the first crow, right? This is the second crow, right? This is the second crow. I'll leave spaces, okay, so that it becomes easier to see. This is the third crow, and this is the fourth crow. Correct? Just before the draw, if you put flip, it flips. So here, for the first one, if I say dot with flip x, flipped x, it stays where it is because it is there in the center itself. It will not get flipped, right? The second one, if I try to flip it, it will go on the other side. See. Third one, if you try to flip it, exactly goes on the other side, right? Similarly, the fourth one. Goes on the other side by the exact amount. So what we are going to do next is this group that we had, right? Nowhere way to remember how many times we have called hop or anything. Right? Just take the last value and add to that. So I'm going to remove all these draws and I'm going to put all of this in a pick stack. That will make a group of this whole thing. Right? So get rid of this draw, this draw, this draw, and this draw. Right? And then put it in a pick stack. So def crows on, they are all on the right, correct? Crows on the right is a pick stack. And what is the pick stack made up of? I'll copy each one of them inside it and just put comma after them. Right? Put a comma. Instead of draw, now put a comma. Comma, comma, and comma. That's it. So this is crows on the right. Obviously, it won't draw. Why it won't draw? Yes, we just made a stack. We didn't ask it to draw. You have to ask him to draw. So crows on the right dot draw. And then what does it take for me to get the crows on the left? Crows on the right dot with flipped x dot draw. and there are, आणि ऑब्विसली कावळे रडच्या पहिली च्या घेऊया. कावळे येतले मॅम, जागेवर येतले, आम्ही कधीच राहतले हाच्या पुढे तेच. I'll do that again, ma'am. You want to scroll up? Okay. I'll share that code. Share the whole code. हय हांगा WhatsApp चालू.
टेन्शन घेता
Done. Shared on WhatsApp.
रिकॉर्डिंग पॉज करता.
Hi.
That is the whole idea. Now, if similarly, here if I remove draw and make a pick stack of that, it's basically now putting these two slides together. And then I can rotate all those slides. And then again ask somebody to draw those. So all those things work. So basic idea here is imagine that picture which I'm projecting somewhere and asking somebody to draw. This is essentially tracing. The axes don't move. It's always at the center. Everything revolves around it. Make sense? Any questions? चहा घेतलाय मी सगळे. So if you see this first crow is a normal crow. But the second one is this crow, which is having this translation. The third one is basically the same thing, correct? That's having one more. And the fourth one is basically this with one more. That's how it's going, one step at a time, implying those same transformations again and again and again on those, right? So how can we build something complex? We'll not do all of that right now, but there are multiple things that we can do just with this. Literally any shape, if you can imagine it, how we can put them together, scale them, rotate or move, we can build literally anything. So let me show you one example of what the transforms can do. I've shared this code, okay? So everybody must have got it, right? So again, now rotating, I don't have to worry about clean slate or anything. I can rotate this whole thing. I can make this whole thing bigger or smaller. I can show that to you, for example, right? So let me just do this. Let me put this itself in a pick stack. Now, how will I put this itself in a pick stack? Remove draw first. Understand one thing, okay? Coding is a process. Follow the process that I'm taking. I never type the whole thing. I'll do something, say dot and press control space and then select. So do not overload your brain in trying to remember what all commands are there. You can always see those commands. And secondly, I will first draw it. And once I know that, I'll put it in a pick stack. I'll not start with a pick stack and then put it into that. So coding is a process. to your students and to the teachers whom you'll be training. You have to introduce them to the process. Right? So follow that process. Now I'll say def crow formation. Correct? And then it's a pick stack. Like this. Put comma here. Put another comma here. There is no comma required here. And done. This is a crow formation. Again, it won't draw. But let me do something. Okay, let me show you all possible transformations that are there, and let us experiment with them one by one. So crow formation dot that's rotated, and I'll currently say 0 because I'm not changing it. Then I'll say dot that's translated. Again, I'll say 0 and 0. Then I'll say dot that's scaled. Correct? 1 means same size. So I will say 1 dot that's rotated and done. There is sheared. Correct? So shear, I'll say 0 for now. We'll see what that does. That's stroke colored. Stroke is you know, like whatever you do with a pencil, that's a stroke. You don't say I'm drawing a border. Right? So I will say it was red, right? So I'll say red. And that's stroke sized. So I'll say something like 4. And finally, I'll say draw. Right? Now I'll see something here. Okay. Now let us try experimenting with it one by one. So there is that's rotated. And I say control and click on 0. And if I give that number, see, it's rotating, right? Can you guess, as I'm increasing the number, why is it rotating towards left? Because if you keep a protractor, right, the numbers increase towards left. So it is using a protractor. That's why they were even shown a protractor there, right? So this is gone something like towards 120. So 29. Oh, it's basically like counting from where it was. So if you consider 90, then this is close to 29, correct? So if you see 10, 20, and 29, yeah. From that point, not absolute. From where it was, because it is not rotating like this. It's like rotating the whole page. Correct? So let's move it back. Let's move it back. Right? We're back at 0. Translated, we have already experimented. Positive value for the X pushes it towards the right. See. And if you start moving it left, it moves towards the left. The whole thing. Okay. Scaling. Scaling is always between 0 and 1. If you say 0, you can't see it. So as you go down, see, it's becoming smaller and smaller. And as you grow bigger, it becomes bigger and bigger and bigger. You can go beyond 1 also. So if you make it 2, it means twice the size. sheared is a very interesting idea. Sheared is the one that can take a square and convert it into a rhombus. पत्ते असतात न्ही कार्डाचे पत्ते, डेक असता पळय, तो डेक दवरलो एका वयर आनी फास्टसो असो सायडी वयल्यान जर पुश केलो न्ही जाल्यार जी शेप तयार जाता न्ही दॅट्स कॉल्ड shear. It's like moving one side towards the left and another side towards the right. That's shear. So what will happen if I try to do that here? If I try to do that on the X side, I'll use the 10 as the value. See, it's being shear, it's getting moved. So maybe like, one would be a. See? Sort of getting sheared, sort of like moving towards the other side. From one part stays there, the other side moves. Right? Color, we already know, we can play with it as many number of times as we want. So brown crows, pink crows, or the black crows. Correct? And stroke size is the size of the pencil used. So if you increase it, see, it's becoming thicker and thicker. If you go the other way around, it's becoming smaller and smaller. So these are the transforms. Now here was a interesting problem. We all drew an equilateral triangle, right? Equilateral triangle सगळ्यांनी केल्लो. Right angle triangle कितल्या जाणांनी काडपाची ट्राय केल्ली? Without using trigonometry of any size. See, equilateral is very easy, right? All the sides are same. So you take a size, rotate it, done. Tension na daga. Right angle has a problem. Two sides are same or could be same, but the other side is not same as that. And to calculate that, you require the information on the angle. Pythagoras. Angle लागतं. तिसरा angle किती? How do we calculate that? It's not even one angle. So can we draw one equilateral triangle and make any triangles out of it? Is a query. Just one and make any triangles out of it. एक ट्रायंगल कसो काडप आमकां खबर आसा. तो घेवन बाकीचे खंयचे ट्रायंगल्स तयार करप. ते जर आमकां करपाक कळ्ळें न्ही, स्टार काडप सामकें इझी जाता. Correct? So that is one thing we can see. झाड काडपाक जाय जाल्यार कशें काडटले? नॉर्मल झाड बरो हे आणि ताका सगळी पानां. So we can try all of that. So let me share this piece of code also. I'll only share the additional new part. Okay. Do try that out. And remember how you change the values. Press Control and click on the number. Okay. Let us try the triangle experiment. We all know how we had drawn equilateral, right? How was an equilateral triangle drawn? We all know 120, 120, 120. So how does that work? Let me say, पहिली काढूया मागीर ताका पिक्चरान घालया. Forward, or we can actually make it face 90 right, towards the right first. Right, forward 100, correct? Left 120, right? This is the first side, second side, third side. And if I do this, it gives me this triangle. Yes, सगळ्यांनी केलं. बरोबर? What I now need is to convert this into a right angle triangle. No trigonometry, nothing. This triangle itself. And that is where I'll follow the process. I'm going to put this in a picture. And then we will apply the transformations and make all different triangles just using this one code, not changing anything. So you see how the code becomes smaller. So def equilateral triangle is a picture that has this in it. So it won't draw now. So what I'm going to say is equilateral triangle, and then I'll say dot draw here. So I can see it. But now I want to make this into a right angle triangle, either on the left or on the right. So let's talk about the process. Code dhadu बऱ्यातले. So you can just quickly write. So I'll rather just share this. Next part, which is the transforms, that is what you can try. Just share it on WhatsApp and copy from there. So now I need to just apply transforms over there. आणि तकली घालपाची गरज ना. Some transform to work on it. That's it. This is something we did without worrying about any trigonometry or anything. Everything worked fine. Now I'm going to say that's sheared. Right? Obviously, there is not going to be any shear on the y direction. So I'm going to make it 0. See? It's already becoming something different. So maybe if I say -1 or maybe 0.5, it may be 0.6. Yeah, there you go. Is it? Not exactly, right? So maybe 0.55 or 58. Does this look perfect now? Yeah, there you go. Perfect right angle triangle. What did it take to do this? Same code, just one transform, get the values right, you've got it. Now, if I just want to make something out of it, I remove the draw part here and assign it to something else. So def right angle triangle is an equilateral triangle that's sheared to this value. Or what if you want to build a cone? Again, equilateral triangle, I'll say, and then dot draw. Up till here it is fine. If I have to flatten it out, that's scaled with two values. Y remains 1, but X becomes 2. See that? We flattened it out. You can even make this 0.5. See? You had a completely different triangle now. With the right set of combination, I can just rotate them in different ways and actually get a star worked out. Or I can flip it in the other direction. So I can say on the X side, this is 0.2, and on the Y side, this is 3. Becomes something else altogether. Right? Did anyone notice this effect? Pixelation? SVG. We'll talk about that. Once we come to SVG, all that thing will go away. Essentially, this is the idea behind anything that we want to do. Draw one shape, work that out, build whatever else you want to do with it. Should we stop here? So I'll quickly mention some activities. One activity we already talked about, right? Create a tricolor background. Okay. And then draw a tree, not that fractal tree. Draw a proper tree. So if I possibly say, maybe I'll share from here. A proper tree that looks like this. Something like this. Obviously filled. This is to be filled with the brown color, and this is with green color. Give it a try. Let's see how it works. If you are thinking in like a turtle graphics way, right, you will actually think about tracing these points. And if you are thinking like a picture graphics way, you will actually make those green color circles and just organize them in different ways so you get this effect. We just given a hint. So give that a try, right? Good enough? Thank you, teachers. We are again meeting 2 weeks later, right?
Yes.
Yes. So we are meeting 2 weeks later. You have enough time to practice on this.
Thanks. Nice one. You always are amazing. Definitely, a good day. Thank you. So, mind you, teachers, Kojo software has been modified by NS to make it easy for you. So, if you see the way it is there, we changed it. So it becomes easy for you to understand. It's what the same language of Scratch that you are doing is here.